Hello, everyone, and welcome back to The Critical Thread. I'm Brian Spellman.
And I'm Andrew Sparrow. So welcome back, everyone, to the continuing series of The Critical Thread. Think of discrete manufacturing. Think of the entire product life cycle, of course, including manufacturing and maintenance. And then think of the best practices that have been developed over the years. And you know, what we call the do's and the don'ts of that critical thread. So with that in mind, ready, set, let's go. So today we are talking about automotive quality management, that essential part of the digital thread in automotive. Brian.
So today we're going to have a fantastic guest. We're bringing on Mike Bradford, who's been involved in the IT industry as an IT manager, a management consultant, and technical consultant on the software side for about 35 years. I believe this means he must have started when he was 7, maybe 8. He's been a materials manager, a part-time college instructor. He's worked in ERP and MES, but these last 30 years have really been primarily focused on automotive industry. So without further ado, let's bring on the strategic business consultant at Dassault Systems, Mike Bradford. Hey, Mike, welcome to the show.
Thanks,
Mike.
Brian. Thanks, Andrew. Good to be here. Appreciate it.
Sure thing. Where are you based out of? I'm going to take a guess. It's got to be somewhere near Detroit.
Very good. Yeah, I'm in the west side of Michigan, so about 2 hours west of Detroit. Probably as close to Chicago as Detroit, but I'm a Detroit fan. If you pick any sports team, and it's Detroit, not Chicago.
You got the mug? You got the Lions mug?
I do.
There you go. There you go.
I'm no longer embarrassed to show this. For a long time, I was.
Good. All righty. Now, everyone, as we get started, please throw your questions in. We're going as what I call inch wide, mile deep. We want to go as deep as we can in the quality management side of automotive, be that ICE or be that EV ACES, as we go along. So please throw those questions in. Brian, let's get us started.
Yeah, so as long as we're going to try to go inch wide, mile deep, let's just start with a, I guess, actually high level question of tell us about your understanding of manufacturing quality management in the automotive industry and why it's important.
Okay. Well, it's defined by standards, like a lot of industries, defined by standards and regulations, primarily IATF 16949. Used to be QS 9000, then TS 16949, which is a standard around quality processes, quality systems, and quality practices in the automotive industry. There are also a lot of other related standards and related capabilities that are important. The biggest one probably is APQP, which is Advanced Product Quality Planning. And that includes a whole lot of subcomponents like PPAP, which is a pre-production approval process, or FMEA, I'm drawing a blank here, failure mode and effects analysis. So there are a lot of components like that. And even if you go back 20 years, something called the TREAD Act, which I bring up only because that one's still in use, still important. And a lot of people see TREAD and think tire. TREAD is actually an acronym. The TREAD Act talks about traceability and recalls and being able to enhance that process for any safety product. So yes,
now the Shred Act was around for what, 20 years, I think, right? So
Yep,
is it
yep.
is this constantly updated that people have to pay attention to?
It does update in terms of what's considered a quality component. So yeah, it does get updated and changed. And like I say, qualities, tires, brakes, seat belts, airbags, anything that can affect quality.
I'm amazed Brian didn't say, does that still got traction today? I'm shocked that he didn't. He lost that opportunity to ask that.
I haven't started the dad jokes yet.
Yeah, you're getting close, I can tell.
I'm sorry I missed that opportunity. I should have thought of that one.
APQP, I just want to go back there.
Yeah.
Obviously focused on quality, customer satisfaction. What do you feel are the hardest parts of APQP, and how are those addressed? Just why you bring it up.
The hardest thing, I think, is it's just so broad. It covers everything from design to execution to, I mean, it's a very, very broad. I mentioned pre-production approval process. Well, that's before you even, that's while the parts are in design. Failure mode and effects analysis. That involves design, the product design, but also the process design. So it's a very broad standard. The book is actually quite thick for it. So that's what makes it difficult, is just to cover everything, because typically it involves multiple systems. So if you can do that in one platform, it really simplifies things.
Gotcha. Yeah, something we've been working on, and I always try to tolerate it back into customer expectations. How do you manage that within APQP, et cetera, et cetera? So good. All righty. Let's take you back. I know you were talking about related standards.
Yeah,
what else we got?
About the standards. Let's talk about why it's critical. It's critical because of the huge number of parts that are produced. Think about the volume of parts. And in fact, one of the key measures of quality in the automotive industry is PPM, parts per million.
Yeah.
So, it's very precise, very significant. And it's driven because failures have such huge costs. For OEMs and suppliers, one of those big costs can be recalls. Recalls can be huge. In 2022, there were 13.75 million vehicles sold and almost 31 million vehicles affected by recalls. Think about that. Huge difference. And there have been more vehicles affected by recalls than sold every year since 1995. So it's a huge issue. And
how long do we keep a vehicle for as an average?
It's a good question. I'm not sure the average anymore. I tend to drive them into the ground and keep them for a long time, but I
don't blame you.
Every 2 years. So I'm not sure what the average is.
Because it feels like, I mean, on those ratios, it feels like almost everything is being recalled, but I know that's not the case, but yeah.
Well, I tell you what, at some point, almost every vehicle is hit by some recall, because remember, a recall hits multiple vehicles can hit multiple vehicles over multiple years. So I know my wife's car has had 2 recalls. My car has had 1 or 2 recalls. So
right.
And then that affects OEMs and suppliers. From the supplier standpoint, another quality failure issue or cost is just premium freight. If I have a quality issue and have to rush parts to one of the OEMs, I could be paying for airfare. But even think about, I want to get my Amazon package tomorrow. Well, sometimes you have to pay extra freight for that sort of thing. So the same thing applies here. And finally, it really affects just-in-sequence suppliers. If you think about just-in-sequence, so if you're not familiar, just-in-sequence means not only do you have to get to the right parts to the supplier at the right time, you also have to get them there in the right order. It's the OEMs really would like their guys on the assembly line to be able to work blindfolded. The next part off of this rack goes in the next vehicle on the production line. So think, if I'm doing seats, I need seat color, I need seat material, and I need, is it power or manual? And even if power, is it 6-way, 8-way, and is it heated? Is it air? There's all these different options for the seat. So I've got a black car coming down the line and it needs a power seat that's 8-way adjustable with heat. That's got to be the next seat that's on the rack that as a supplier I sent. If it's not, that becomes an issue. And if in fact I shut down the OEM's production line, either because of a wrong part or a quality issue with that part, they will charge $10,000 to $60,000 per minute for every minute they have to stop to correct your error or to fix your quality problem.
So it's a efficient process when it's working right, but if you get that thing messed up, that's an expensive problem.
It is. It's a very expensive problem, one that you don't want to have.
Yeah.
And it's, in addition, it's critical to image, and it's also critical to the environment. If you think about the environmental impact of quality. If you scrap parts, there's an environmental impact to that, but then you have to either repair or remake a part. There's a CO2 footprint impact on that. So there's all sorts of impacts to quality, and a lot of reasons it's so critical in the automotive industry.
Yeah.
So we do have an answer to your question, Andrew, of how long.
I saw that.
Yeah, Dan Wilson, I should know his name, I've talked to him before, has chimed in and said that 10 years is apparently the average for, and Dan does know about cars. I think anybody who's watched our news show the past couple Fridays should know that Dan is knowledgeable about he's a collector. But yeah, 10 years is apparently average. And then
so that basically means, if you do the math, that's about a quarter of vehicles are recalled if you continue selling about 14 million a year. Yeah. Wow.
And
interesting.
To tag on to, I think, what you just said at the end there, Dan also just asked us, how do you address environmental sustainability and compliance with environmental regulations in your quality management process?
So again, a lot of that is around just ensuring that and we'll talk about that more a little later, but a lot of it has to do with enforcing the right quality steps at the right time in the process to ensure maximum quality. And compliance can be driven, should be driven really by enforcement systematically. I mean, if you've got quality processes, if your processes are sustainable, if they comply to industry standards, well, you want to make sure those processes are enforced. Because as human beings, we always tend to do the easy thing, the fast thing, or the thing that we know the best, and that's not always the most efficient or effective from a quality and sustainability standpoint. So, where possible, systematic enforcement, I think, is important.
So it sounds like there's a lot going on, a lot of compliance standards, regulations, and everything that have to happen here, whether it's environmental, like Dan brought up, or all these other factors that you've been saying. So how are you able to ensure that you're in compliance with all of these standards and regulations?
Okay, great question, and it really does start with the engineering and design side. If you've heard the term DFX, design for
excellence.
Design for manufacturability, design for quality. It starts with the design. Are you designing a product that has quite high quality built in? And then based on that design, you want to have quality and control plans driven by FMEA. So failure mode and effects analysis. Again, that should be systematic and driven by the product design. So there's really two types of FMEA. There's DFEMA and PFEMA. Design failure mode and effects analysis and process failure mode and effects analysis. So it starts again with the product design itself. But then once you've got the product design, now you have to design the processes and define the resources and the steps and everything needed to produce it. And you want to do FEMA there as well, because there are opportunities for errors in both of those places. And then the control plan, what the control plan does is it takes that FEMA. So FEMA identifies all the potential points of failure. It takes that and puts together a plan, quality steps, measurements, the things that you can do to prevent those things from happening. And it should involve, you should have some standards because, every time you drill a hole, well, you want to make sure the hole is the right inner diameter. There are certain things where you can share some of those control plans across multiple products with some minor adjustments for size and that sort of thing. But having that fully integrated with product design, process design, right into the execution side is key. And that's where we talk too about digital thread. So starting with the product design into the process design and on into execution. And one of the things that we do as a company that we feel enforces that is we do what we call model-based systems engineering. So instead of the design person creates a file and he hands that file to the process design person and he builds the processes and defines the resources. And then he just hands that to the execution person who takes that to figure out work instructions and that sort of thing. With model-based systems engineering, there's one model. Everybody's working from the same model. So now when this guy makes a change over here, he doesn't have to tell this guy who has to tell this guy. There's no delay because they're working from the same 3D model. So that collaboration becomes inherent in the process. So that digital thread then design, process, and execution. And that then should drive, based on those control plans, inline quality and offline quality. Inline quality being those things the operators can do, measurements and inspections and the things that the operators do as part of their job. And then offline, things like end-of-line testing, putting it on a pressure tester, putting it on a torque tester. So all the end-of-line testings and quality stations and so forth. And both are important. And those systems need to be adopted corporately, but enforced as much as possible systematically. And then inherent in all that is the ability to do traceability and containment so that if issues do occur, you can identify them.
Great. Thanks, Mike. Just as a foundation, I guess, for compliance with the standards and regulations, I'm assuming a good quality management system, number one, as a foundation. Document control would be fundamental to the whole thing.
Yeah, absolutely. As well as things like from a traceability perspective, and I think we'll probably talk about this in more detail later, but the AIAG just released a new traceability and containment standard, and one of the keys there is having all of your traceability data in one place, not some on this system, some on paper over here, some on this system, but centrally located so it's accessible.
Right. Got it.
These may be some questions that you're already planning on addressing later, so feel free to tell us, hey, we'll get to that. But I just want to bring these up as we had a few folks chime in with some questions here. One was Greg is asking if you have any examples of cost-saving initiatives that don't compromise quality in the manufacturing or quality and safety in the manufacturing operations.
And a lot of that has to do with process. We don't talk to that specifically later, so I'll address it for just a minute here. Cost-saving initiatives like, well, even, that whole just-in-sequence thing, it's difficult, it's complex, but it does save costs. It reduces shipping costs. You're not shipping huge quantities. It reduces assembly costs at the OEM because they're not having to look for parts and do a lot of material handling and material storage. So material management, good material management, simulation of processes to ensure they're efficient, and that we will talk about a little later. And other initiatives like that. Anything that reduces waste, if you're lean, reduces MUDA, anything that reduces waste, increases efficiency. Those things can really have a direct impact on cost savings. And if done right, they don't negatively affect quality.
Yeah.
I think I think this ties into that, and also is one where I think we're getting to later too, but the predictive maintenance and preventing quality issues. Is this something that obviously it ties in, because if you can predict them, it helps. But do you have...
Let's hold that one until we start talking about some of the problem solving and collaboration later on, because it is absolutely, it is a value, and we'll hit that later.
Brian, there's one from Zachariah here. I don't know if that's, it's to do with tools and methodologies. Is that something we're going to maybe talk about a little bit later, but maybe you could touch on that now?
Sure.
So the question was examples of specific quality management tools or methodologies that have proven effective in improving manufacturing quality within the industry.
Yeah, we've already talked about some. FEMA and control plans that's why they're really required in the automotive industry, because they do improve manufacturing quality. We'll talk about others as well, but those are two that, they're kind of core. If I look at the APQP guidelines, FEMA and control plans are core to that process. So.
Yep. Great. Good. So So step back, let's drive forward. So how do you track and measure the KPIs, the key performance indicators related to manufacturing in a plant?
Okay. There again, it's typically both manual and automated. You want to automate as much as possible. One way is to provide visual quality tools where you can bring up a 2D or 3D model of a product. And I think we've got a video to demonstrate that. Yeah. So to make it easier to document quality issues. So instead of taking a piece of paper and marking down, oh, I had this issue on this area of the part, or even on a screen picking an issue and the part, by doing it visually, by giving the operator a visual model, it's much easier for the operator to say, this is where the problem occurred. So it really makes that identification of where issues occurred and what they occurred, what the issues were, easier. And in addition, then we can do what we call a heat map so that we can later on, when you start into the collaboration and problem solving area, you can very quickly see, well, gee, 80% of our issues are a bent part, this part bent in this area. Now we know where to focus our quality improvement efforts as well. So providing visual quality tools is a real help.
Right.
Linking directly to shop floor processes with integration to equipment and that sort of thing, to sensors, to IIoT devices, that can help. I do want to do an aside here about IIoT. IIoT is a fantastic, relatively new capability. Be cautious that you don't collect too much. We had a customer that they basically wanted to collect everything they could, and they got overwhelmed with data and could get very little information out of it. So don't collect too much. And remember, just collecting the IoT data is not enough. It needs to be contextualized and it needs to be actionable. In other words, what's the context? What does it apply to? And then actionable. What actions can I or should I take in relation to that? And it's not a separate process from MES MOM. That's a problem I saw early on when IIoT was first an initiative in a lot of companies. They had one group doing IIoT and a separate group doing shop floor applications like MES and MOM. Well, those two should be tied together, right? They
100%.
have to work together. So I don't see that as much anymore, but the two need to go together. And then,
don't they? Shouldn't they be? I mean, all of it should connectly tie back into the KPIs. And with that in mind, what do you see as the typical quality KPIs for automotive?
So I've mentioned one, right? PPM, parts per million, is key. Right first time, we've referred to right first time. That's a big one. Scrap percent, which has been around forever, but that's still a key quality measure. OEE. OEE is overall equipment effectiveness, but there are three components to OEE, and one of those components is quality. So that is really a key quality measure as well as a key machine effectiveness measure. And then having statistical process control, SPC, to track what's going on the shop floor and see trends and that sort of thing. And that any and all of those can and should include alerts. So the example I like with SPC, we had a customer who they configured into the system, if they had an SPC trend that was 4 dots in a row in the same direction, even if it was still within their control limits, they would create an alert. Because remember, there's variation in every process. And it's going to go up, down, up, down. If it goes up 4 times in a row, that indicates there's some problem, underlying problem. And eventually, even though you may still be in control, you're going to go out of control. So having alerts built in is valuable as well.
2 or 3 other KPIs that spring to mind. Downtime.
Sure.
Customer complaints. And would cost of quality be another KPI that you would want to look?
TCQ, total cost of quality, is another one.
Yeah. Okay, great.
Does your life just involve, do you have an acronym for everything?
I have a TLA, that is 3-letter acronym, for almost everything. Yes, absolutely.
I can imagine Thanksgiving dinner at your house is like, hey, please, instead of pass the mashed, PTM, pass the mashed potatoes. I don't know. You've got all these things happening. Yeah. So you're talking a lot about data and now are things that involve lots of data. You gave us some warnings a second ago about don't collect too much, which kind of made me wonder, is this something that you see as and this may not be something I don't think we even gave you any idea this question could be asked, but if you have with what AI is doing to our world now, do you see this coming into play? And or actually, Elena also asked something similar here.
Okay.
And do you see that artificial intelligence and machine learning are going to play a role in the analysis of the data you're talking about, and in predictive quality and analytics? I can say words, and prevention.
Sure. Yeah, absolutely. That's one of the things where I think artificial intelligence can bring value. It's the fact that it can slog through, millions and millions of data elements and identify trends and identify, trends both before and after issues, and look at analytics and start to identify where they can provide value. So yeah, that's, I think, the ability for predictive maintenance based on AI, for predictive quality analytics, and that sort of thing. That's really, I think there is a real future there in terms of how AI can be used in manufacturing. I think that's a great question, Elena. I think that's definitely an area that I know we've got.
It's the big one.
Yeah,
that's got to be Industry 5.0, hasn't it? I know it was in 4.0, but it feels like the next wave.
Yep, I agree.
Yep.
I agree.
Yep. So can you share an example of a specific problem you've encountered in the past that kind of relates to QM and how you actually resolved it?
Sure. And I'm going to go maybe a little low tech with this, but
okay.
we had a customer, an automotive OEM, who was experiencing some significant PPM issues, parts per million quality issues, and most of them were around something that sounds very simple. It was labeling and having the right parts labeled the right way and in the right containers when they get to the OEM. You say, what does that have to do with quality? But in automotive, delivery is a key component of quality. It's got to be there, the right part labeled the right way so they can use it effectively. So they did several things. We helped them do several things to address that. First, they went to a Kanban system. So if you're not familiar, Kanban is a visual pull system where I'm no longer building to an MRP plan. MRP is still valuable in that to look at long-term trends to make adjustments, but basically I get orders from the customer that drives a signal to produce these particular parts, which drives a signal to provide these particular components, which provides a signal to pull components from the supplier. So it's pulled through the system rather than pushed. So that was the first thing they did to minimize some of the mess inside the environment. And then they added labeling and scanning at every step of the process. So now, based on the Kanban signal, which has a label, a barcode on it, I know what part I'm producing. So I can scan to know what to produce. Now I know what components I need. I can scan the components to make sure I'm using the right components. I get the label automatically based on what I'm producing, based on that scan. So by scanning at every step of the process, and by system enforcement of making sure it's the right parts in the right place at the right time, that I'm using the right components, that there are no quality issues with the components I'm using, and that sort of thing. And by driving that through the process, they were able to significantly, exponentially improve their PPM. In fact, after that, a couple years after implementing that, they had 20 plants that had 0 PPM for multiple years. So
wow.
Yeah. Millions and millions of parts shipped and not one quality issue.
That's impressive. Along the lines of these issues, and I guess to bring in some more acronyms for you. So Dan is saying that looks like the OEMs and suppliers ranked problem solving and customer specific requirements as the most critical issues impacting quality. So what's the best way to handle this?
Okay, so that's going to go to, we're actually going to talk a little more about collaborative problem solving and some tools available to use that. But that's just a sneak preview. It has to involve multiple departments. It has to be cross-functional. You can't have one group problem solving for the whole organization because problems can come from multiple places. So, and we'll hit that in more detail in a little bit.
Okay.
So working together. Okay.
Good. Okay. So containment. Let's talk about that. What is a best practice approach to containment? In other words, if a quality issue occurs, how do you manage the impact of that?
Sure. So first of all, let's kind of define containment versus quality. And I think so. Containment is kind of the flip side of quality, right? Quality is the preventative things that you do to prevent any nonconformance. It's things like inspection, sampling, quality tests, SPC. They're routine things that you do every day. Typically, your line workers are doing that as part of their job, and it incorporates your preventative measures, and it's supposed to improve quality and reduce related costs. Containment is the other side of that coin. Containment is what you do when a nonconformance, in spite of all your efforts, some sort of nonconformance has occurred and it's escaped those preventative measures. Typically, those are driven by unpredictable or unknown root causes. They are hopefully rare events. If they're common, you've got more problems. Typically, they involve quality managers and engineers, so it's a little more costly personnel that are involved. But it also can help identify new preventative measures and mitigate risks. So it should be part of a continuous improvement process. There recently, in 2019, there was a new standard released by AIAG and VDA around containment and traceability. In fact, I was part of the work group that built that standard. So it starts with traceability data beyond just genealogy. Some people use those terms interchangeably. When I say genealogy, I'm talking about parent components. So this parent, this engine serial number, these 8 piston serial numbers. So it's the serial number, lot number of all the components that are key to that part. Traceability goes beyond that to also include what machine was it run on, what operator was running the machine, what torque values were received, what were the quality test results. So it's all that surrounding data that is more than just a parent component genealogy. So part of the standard is then that all that data should be integrated and automated and stored automatically. So one place for all that traceability data. And again, over the years, I've gone places where they've got traceability in their test systems. They've got traceability data on paper from some of their stamping machines. They got traceability data in their MES from their manufacturing processes. So it's scattered. It's got to be consolidated. That's part of that standard. It's got to be consolidated. It's also got to have multiple search criteria. Just saying it happened in this date range, which used to be how they did it, it was this part on these 3 days. That could be thousands and thousands of parts in the automotive industry. It's not good enough. So you got to be able to search on more than just date, multiple search criteria, and visibility on where the part is today. So, we've done our analysis, and the problem was with the lot of camshafts. Well, we've got some still in a box in that lot. We've got some that have been machined and they're now in another area in the shop. We've got some that have gone to the engine manufacturer and they're now sitting on the dock, and some are in engines there, and a couple have gotten into vehicles and are at the OEM. You got to be able to identify as much as possible where all of those are so that you can put a fence around them and check them out. So, and you need the ability then to hold those both internally and externally, but also current holds and future holds. What by a future hold, I mean, so let's say we determine it's not just that it's this lot of camshafts when Mike did the machining on machine 10. So Mike's part of the problem because anybody else who machines on machine 10, Brian does it and it's fine. Andrew does it. It's just that Mike guy. So now I need to be able to take those 3 criteria and say not only anything that meets those criteria today is on hold, but if I find that out while Mike's still working on machine 100 on camshafts, anything that he does off that machine until we figure out the underlying problem, get him retrained or whatever, anything that meets those criteria has to automatically go on hold because we need to validate the quality before it goes anywhere. So that's a future hold. And if you do that, there's huge value in that. We had one customer who's their CIO called our CEO and said, we had a 19-day payback on your MES mom solution. Now, we know there's value in our solution. That's one of the things we brag about, but 19 days. So the question was, how did that happen? And this is what happened. They had a quality event before implementing our system. They were like many, they had different traceability data in different places. It took 2 people. Several hours to identify just which parts might be affected. And then they really only had a date range to go by. So the fence, the bookends were thousands and thousands of parts that they had to go out and touch, put their hands on, inspect, some in their plant, some in their customer plant.
Yep.
They had a very similar event in terms of both the number of parts affected and cost of parts and so forth. 19 days after they implemented our solution, one person was able to identify the bookends in a couple of hours. And it was a few hundred parts instead of a few thousand parts. So they figured they told us the result was over $1 million savings in a single event. If you do that right, you don't want recalls, you don't want quality issues, you don't want to have to do containment. But if you do, there's huge value in that, if it's done correctly.
You bet. Great. Good example. We got lots of questions coming in from audience, by the way, Mike. I think one of them, we've got like global supply chain issues. I'm going to come on to that a little bit later and talking about kind of supplier quality, et cetera, et cetera. One thing which I wanted to ask, which I'd forgotten to ask, which was how you approach the identification and root cause analysis of defects or non-conformities in the whole manufacturing process.
Yeah, and I'm glad we went back to that, because one of the questions kind of related to that too. So obviously it's data-driven and people-driven. You have to do both. And hopefully you've got some sort of visualization. We talk about having the virtual twin experience. And we've got something called the manufacturing control tower, which there are a lot of purposes or a lot of functions for that. And I think we have a video for that one as well. But there are a lot of purposes for that, but it gives you a real-time or near real-time view of what's going on in your plant virtually. So it's kind of like you can see your virtual 3D model of your plant. You can see what's going on right now based on input from IoT devices, from sensors.
I'm going to interrupt you for a second. Yeah. Do you happen to remember what that video was called?
I think it was just either MCT, another TLA, either MCT or Manufacturing Control Tower. Maybe our TLA.
I'm gonna let you talk without the video for that one, because I'm
okay. That's fine. Yeah. That's fine. But the value here is and we can tie in KPIs right on the screen and performance measures right on the screen. So from one standpoint, I can see what's going on in my plant from anywhere in the world. But related to problem solving, I can also get alerts when something happens that shouldn't. And for me, this manufacturing control tower is kind of like a new age Ring doorbell. If you get your Ring doorbell and you don't pick up the phone quick enough, you don't see what's there, but you can go back in time, scroll back and see what caused it to go off. So you get an alert on the manufacturing control tower, and you can actually go back through time and see what happened in your plant leading up to that. Where were the parts? What were the inventory levels? Who was doing what where? So it can really help in that problem solving, because it can help identify the problems that led up to that issue. And it has to be collaborative. Whatever tool you're using, it has to be collaborative and cross-functional, because problems from anywhere just about can affect your quality. There need to be some strong real-time analytics with the ability to, I hate to use the old term, but the old term slice and dice, the ability to take the data and look at it this way and look at it this way and take out this piece and put in that piece, and because that can really help find it. And then visual identification. I talked earlier when we talked about the visual quality defect tracking, about having that heat map. Having that kind of consolidated data about quality issues really helps in identifying, focusing your improvement efforts, and identifying underlying issues.
So I was going to name the author, but I would have embarrassed myself because I've forgotten. But TQM, and much of that focuses on things like a culture of quality. What strategies have you used to foster that culture of continuous improvement in your overall quality management practices?
Well, there again, it involves people and systems, but that culture piece has to be very people driven. You have to have, and so, we mentioned that I've been around in this industry for 35 years. Thank you, Brian. I did start when I was 7 years old. I appreciate that.
I did the math.
But any system that's going to be effective has to involve, and I've talked to this as a management consultant years. I mean, I've been talking this for many, many years. I've done all sorts of presentations on this, but successful implementations, that sort of thing. But they all involve executive support. There has to be executive involvement and executive support. And particularly when you're talking about something like this that involves the culture of the company, it has to be driven from the top down. So that's number one. And number two, where possible, having systematic enforcement. I talked a little bit about that too. Employees have to understand what the quality checks are and why they're important. And I always like, I mean, our employees are pretty smart, right? If I just tell them what to do, I mean, if they're conscientious, they'll probably do it. But if I tell them why, they're smart enough to understand that there's value and why they're doing that. So systematic enforcement with why it's important. So those two things can work together to help drive that cultural change. Those three items.
What about kind of the Kaizen approach to things? Do you think that has value in automotive?
Sure. In fact, I've got a good example that is not automotive,
from a cultural perspective again.
From a cultural perspective. So we have another company that uses our software called L'Oreal. Anyone who's familiar with the makeup industry at all, who's married or has a significant other, or everyone knows L'Oreal, right? And they are a very lean company, and they do monthly Kaizen events. So they will pick a process that they feel can be improved, and they'll do a Kaizen event every month.
Right.
Then take that process, and talking about enforcement, they take that process and update it systematically. Wherever the system, people touch a system in that process, they update the system to reflect this new process. And then they roll that out to 32 to 33 plants every month. So every month, 33 plants are getting an improved process, but also a systematically enforced improved process. And then part of that too, I kind of skipped over a couple of things, I guess. Part of that too is feedback from manufacturing to design. Any sort of continuous improvement has to involve feedback. It can't just be, we talked about that digital thread from design to execution, but it has to go back as well, because the guys on the shop floor, the ladies on the shop floor, they're going to find issues as well. And so they need to be able to feed that back. There needs to be a process for that. And then having some tools that encourage collaborative problem solving and review. And we'll talk about one of those in a little while, but having tools to help and to support that. And then that flexibility, like the L'Oreal example, having that flexibility to change processes when new processes or improved processes are identified.
Great. Good. So how do you ensure, Brian, go ahead.
I think you kind of just touched on this, but just wanted to kind of elaborate a little bit. Joseph asked us if you have strategies to help ensure that your quality management system is adaptable to changes in customer demands and market trends. So I think the example you just gave is a great start to that. Do you have any other thoughts on some more?
Yeah, just again, it's got to be, I'll use another old analogy somebody gave me. Some systems are like cement. You can put them in any shape you want. They're thoroughly mixed and permanently set. Once they're set, and it's very difficult to change them. So you want systems that enable configuration and change, because your business, if you're in a state of continuous improvement, which you need to be to stay in business for very long, really, especially in automotive. So if you're in a state of continuous improvement, you need to have systems that enable you to reconfigure, change, adjust systematically for the new processes that you're implementing. So it just that adaptability to change is really, it's got to be inherent in the solution, that it's configurable, that you can make adjustments to it to meet your new needs.
Cool.
Great. All right. So how do you ensure the manufacturing process is capable of consistently producing the high quality components or products that we're looking for?
Okay. So that goes back to DFX, what we talked about earlier, the whole design for excuse me, I've got Brian's talking disease. Design for manufacturability and design for quality. And we do that a lot with, I've referred earlier to virtual twin. We do a lot of that with the virtual twin and simulation and optimization virtually. So in this example, you can see that we've got a new assembly line that we're going to put in. Well, we can set that up virtually first in a realistic model, that is in a virtual model that is realistic to life, both in terms of layout, size, relationships, but also performance, so that we can do a virtual twin and ensure that embed KPIs and ensure that the line works most effectively for what we're trying to accomplish. Ensure that product goes through the line without bottlenecks. Ensure that the equipment works effectively. This one has a robotic at one end of the line, a robot at one end of the line. We had we had a customer that was doing a new line that had 4 robots working together that were loading materials, and they laid it out 2D on CAD, and we said, let us virtualize it just to make sure. And at first they were hesitant; they didn't see any value, so we said, well, just let us try it. So we tried it, right? And we have a partner that'll go through and scan an area and build a 3D point cloud of the area, so you've got an accurate virtual model. You can drop in virtual models, 3D models that you may have, like the robots. So we did that for this line, had it set up the way they had it set up. And what we found is one of the robots could only reach about 1/3 of the pallet where the materials were coming from that robot was supposed to provide to the line. So they had taken into account collisions. The robots didn't collide. They were spread out far enough, but they didn't take into account where the robot has to reach to get the material.
Yeah, elevation, etc.
Yeah. So by virtualizing it, we saved them thousands of dollars, because they would have set it up and then they would have had to stop production and reconfigure and make sure the robots don't collide, but make sure they can reach all the materials, make sure they can reach the line. So that virtualization, simulation, and optimization is hugely valuable.
That's great.
Yeah, and then SBC and real-time KPI dashboards and that sort of thing. So all of those things help ensure that the process is capable and consistent and so forth.
Yep. Let's jump outside of the factory for a moment. We've got a question from Zachariah related to supply chain suppliers. I'm going to ask a question in conjunction with this. So how do you handle quality management in a global supply chain where parts and components may come from various locations around the world? And combined with that, I was going to say, supplier quality management, how you ensure that they meet the standards for automotive manufacturing. So I don't know if you can kind of all encompass answer both of those.
I'll try and talk to all of those. So in terms of global supply chain, if it's internal to your company, that makes it a little easier, because you can enforce global processes for quality standards and that sort of thing. But you've also got suppliers that have to be part of that. So then it becomes part of that whole supplier measurement, supplier communication chain. So things like having formal, systematic ways to track PPAPs, make sure that the suppliers are going through all the proper steps to ensure that product quality is good before you start full production. And then tracking things like part per million per supplier, delivery performance per supplier, and even having a supplier portal. I've worked in several organizations where we implemented supplier portals so that suppliers have real-time visibility into how they're performing, and you have real-time visibility into how they're performing, and you can do communication via that portal and so forth. But the thing to remember is all of this should be a partnership, not a hammer. You don't want to just beat the suppliers up. And I know in the automotive industry, historically, there's been a lot of that. But that is really not the most effective way to do things. It has to be a partnership where you can use that portal for two-way communication to help each other improve and so forth. And then the other part of quality on the delivery side is having tools to do global logistics planning between plants, especially if it's an internal supply chain. Having a tool that can look not just at planning within your facility, but planning across facilities to ensure that you're balanced in terms of what's come from where, so you're taking advantage of the most effective transportation methods, and having the least environmental impact possible with those transportation methods and so forth.
Just to step back, even before all of that, what about supplier selection? What can you get into from a quality perspective when you're trying to pick the right one in the first place? Because you're right, once you've picked them, you've got into a marriage, so you've got to make it work, be collaborative, be partners. But what about before that? How do you find the right one?
Yeah, that's a good one, because that can be difficult. It's like hiring a new supplier is like hiring a new employee, right? You have there's a lot of analysis and evaluation. Certainly, if they've provided parts to if this is a new program and this supplier has provided products to you before, that makes it a little easier. You know what their history is in terms of quality and so forth. If not, then it becomes, I think, a much more manual thing. You got to go on site to the supplier and look at what their quality practices are in their plants. I mean, we've all got connection in this industry. Talk to other companies that are using them as their supplier and find out what their history with them is. And there are some industry measures on suppliers that are available to use as well. So it can be a challenge.
You're talking a lot here about about quality and the quality standards. And sometimes maintaining high quality is something that's going to take more time, right? And more cost. So how do you recommend finding that balance between efficiency, cost effectiveness, and having high quality?
That's a great question, because you're right. There's quite often a certain amount of tension between quality and things like throughput, which are efficiency measures, right? How do you improve throughput? Well, you take things out of the process. How do you improve quality? Well, you add quality tests and measurements in the process. So how do you do those two together? I've got another customer example. We have a major engine manufacturer that uses our solution in almost 30 of their plants. And the first plant that they rolled out was one of their more complex. They produce between 400 and 500 engines every day, and no two coming down the line are alike, at least unless it's just coincidental. So very wide variation in products coming down the line. And they had significant quality issues, and they were essentially handling those issues with just throwing manpower at it to make sure, because their outside quality measure with their customer was good, but inside their total cost quality was quite high. So what we provided them was, number one, a great deal of visibility into what's coming down the line, what are the requirements, what components are needed. Number two, we gave them a very hands-off user experience. Their operators don't, as long as things are going normally, the operator never has to touch a keyboard or a mouse or the screen. The operator has to scan parts for traceability and that sort of thing, but they don't, unless there's an issue, they don't have to. It's very hands-off. Integration with multiple tools. So for this particular customer, multiple tools and systems. So for this particular customer, we really tied their whole line together. So their ERP system determines the sequence of engines coming that are going to go down that line for the day. So we take that sequence from the ERP provider, and now we know engine one is this configuration. This is all the components that are required. So we tell the operator to scan this particular engine block to an RFID-enabled pallet. They do that. We verify that that block has no quality issues, not on a quality hold, and it's the right block for the engine they're producing. Then we actually drive the conveyor system, and at every station there's an RFID reader. If our RFID reader reads that RFID tag, based on that tag, we know the engine type and all the configuration for that engine at that particular station. So on the operator screen, they see their specific work instructions for that configuration of that engine. They see what components that they need to use and which ones they need to scan for traceability purposes. If they've got line side fasteners, nuts and bolts, and that sort of thing, we use a pig to light system. So which fasteners do I use? Well, the ones with the green lights over the bins are the fasteners I'm going to use for this engine. And it drives that same demand through to the supply of products to that line. So and then we obviously enforce all that. So they can't move that engine down the line until they do scan all the right components. And the torque, we're tied to the torque gun. So we feed the P set, the program set to the torque gun, the value, the angle, and that sort of thing. And then we collect the actual. So if there's a problem with the torquing, we let the operator know. So it's fully integrating all the activities, giving them better visibility of what's on the line, simplifying work instructions for their operators so they don't have to look in a book, they see it on screen. Tying all that together, they were able to improve their throughput by more than 25%, which is a huge throughput jump. Yeah. And they were able to reduce their internal quality claims by 90%, 90%, which is huge. Wow. But like I say, they were just strong-arming things to make sure there was quality in the process before. So it was a huge efficiency improvement and quality improvement for them.
Yeah. So if you get a system like this all set up and ready to go and it's working, but then what do you do to help ensure that these strategies for your quality management system are adaptable to the changes in the market trends and in the customer demands?
Yeah. And there again, that's where that whole idea of a configurable solution comes into play. It's got to be something that you can change and that you should be able to change, not have to go back to the software provider and say, hey, I need this done, because that can get very expensive, right?
Yep.
So you need something that's got the flexibility for you. And some, we have customers that do those changes on their own. We had a customer that in farm equipment that he had 6 plants on a campus and they had a paint line in each plant. Well, they built a 7th plant, which was just a paint plant. Well, that totally changed all of their manufacturing processes, right? Because now everything they do, get their raw steel in, they stamp, they weld, they stamp, they cut, they weld, then they send it to paint, and then it gets distributed to the assembly plants. Totally changed their whole process, and they wanted to integrate that paint plant to the rest of their solution. They did it all themselves. They were going to do a factory showcase for us, let other customers walk through their plant. And we went down to prep for that, and they said, we got to show you our new. They had done all that reconfiguration themselves, no help from us.
Wow.
We have other customers that do come to us or come to an SI, like XE Innovations, come to a supplier or an integrator to help them with that. But regardless of how you do that, you have to be able to do that.
Yeah. So we got a few minutes left. I just want to jump on a couple of kind of people areas, things like cross-functional teams. But firstly, how do you ensure the safety of workers and whilst maintaining integrity of the processes?
Okay. And once again, that starts with a design. And here again, we'll use virtual twin for that. We actually showed a virtual twin we showed the analysis of the line but there's also a virtual twin for people, an ergonomics capability, so that we can view. In this case, there's a process to put a drive spindle into this gearbox. And so we've defined the process in the process planning side of the house. Now we want to put that into the actual manufacturing process and see how it would work with a person, with a human being. Can they really do this? Does it risk injury and that sort of thing? So now we see if the person can reach it, how they can put it in and so forth. And we can do that with multiple different mannequins, different size people, because not everyone's the same. Mm-hmm. So we have to notice we're changing the size of the person. So we've got, in this case, 4 different ones that we're looking at to indicate various different sizes of people. And then where do they have to reach to get that spindle? Where do they have to reach for that? So that's in a little box that's in front of the operator. We're going to kind of teach the system that this comes from here, so that we teach the system where the operator has to reach to get it. And then we can run the simulation, and we see it's not going to work. There's a bar in the way. We can't, the operator can't reach through that bar. So now we need to make a change. How do we fix this issue? How do we solve this problem? So again, by doing it virtually, we don't have to do a bunch of manual reconfiguration of a line or that sort of thing. We can virtually make some decisions and try some things. So the first thing we're going to do is we're going to put the spindles in a box horizontally instead of vertically, so that it requires less space. So we pull out the old box, put in the new box, and we run our simulation. And what we see now is, once we reteach the system, that's where it is, that now the operator can reach it. But now we want to look at, is there any risk to the operator? Notice the yellow dot. No matter how tall or short the operator is, they're risking back injury because they're leaning too much. So now we want to reconfigure the line to put that closer to the operator to make sure they aren't risking injury. And now 3 of the 4 are good. There's still a potential shoulder issue with a very short employee, but we've fixed that problem for most employees and done it very virtually before putting it in place on the line. So it's, again, doing it virtually really helps. And then there's also augmented reality and virtual reality. Right. I want to differentiate those two quickly. Virtual reality is a fully immersive environment, right? You see nothing real. So that's going to be a full headset, and all you can see is virtual. But that is a great training tool. So training the operators on how to do things safely virtually first. And that way, if they do something that they stick their arm in a press and the press comes down, it's virtual. They're not going to lose their hand, right? So doing that training virtually first to embed the safety processes there. And then augmented reality enables the employee to see reality, but also see virtual on top of the reality. So they can see, this is where I have to reach. This is what I have to measure. This is what I have to, they can see what they need to do on top of what's physically there. So those can really help. And that's especially critical now with the workforce challenges we're all facing. I always talk about retirement, replacement,
Yep.
retention, and image, right? We're losing millions due to retirement.
Yep.
Replacing them is very, very difficult, and retaining them once we're replaced is difficult. And in manufacturing, the image is kind of tough too, because we don't always have a cool image in manufacturing, but tools like AR and VR can really help address those issues.
You bet.
Yeah.
You bet. Okay. Let me go cross-functional team just for a moment. What role, I know you touched on it earlier, cross-functional teams play in ensuring that the whole QM success. How do you collaborate with different departments, etc.?
Well, again, we talked about earlier, all areas can be affected by quality. I mean, besides production issues, quality can be affected by materials, if they were stored wrong or handled improperly. Quality can be affected by missing materials, obviously affecting your right first time. Quality can be affected by maintenance issues. Somebody talked about predictive preventive maintenance. Maintenance issues can cause quality issues, and improperly trained or uncertified employees. So you really need to have cross-functional teams to successfully diagnose issues. And it helps to have a collaborative tool to facilitate that. We've got something we could use called 3D Lean, which is a collaborative tool that is useful, that can be used from anywhere in the world. Notice in this case, we've got a model of the shop floor. Here we're looking at where we have some issues. We're looking at a live production screen. So we're going to have a meeting to talk about that. And notice you don't all have to be in the same room. This is truly a collaborative team. Our company uses it for multiple different purposes because we can all be looking from 6 different countries. We can be looking at the same screen and seeing on that screen exactly what someone else is doing. So it really enforces collaboration. It enables you to, you can use things like a Ishikawa diagram and other tools to problem solve. You can document everything. And, everyone loves, if you go to stand-up meetings or problem-solving meetings in most plants, they're standing in front of a whiteboard where they're writing things down and they're doing sticky notes, which is great. Well, what happens later on? So the problem is solved. I'm going to take that sticky note and I'm going to wad it up, throw it away. Well, this tool enables you to do the same thing with virtual sticky notes. But now when you're done, you mark it complete, but you've got the history of what was done and who did it. And you can assign issues across regions. So across silos, if you will. So if I see and I identify an issue and I think it involves maintenance, I can assign it to the maintenance department. I can't assign it to an individual in maintenance, but I can assign it to the maintenance group. And then if they're on that screen, on that app now, or if they come back later, they'll see that they have an issue assigned to them. And they can look at all the underlying information and collaborate to solve it and assign the right person. So it enables you to collaborate across departments, to visualize 3D content, including designs and that sort of thing, gives you the digital whiteboard. And it uses data from multiple parts of the organization. So it's really inherently collaborative and really enables that collaborative problem-solving capability.
Sounds good. Sounds good.
Wow.
I think we're there, Brian. What do you think?
Yeah, there are a few audience questions we didn't get to, so I'll have to do maybe another episode with Mike in the future. But this has been, I think, super informative, and I've learned a lot. Hope our audience has too. But yeah, this is you're a wealth of knowledge, Mike.
Or at least I know how to talk a lot. But I appreciate
great.
I appreciate your comments.
You're good at pretending to know a lot. Is that better?
Okay.
That is quality management in automotive. We got to talk about a few other areas. I think we may need to talk warehouse with you as well, because we're tying a lot of this stuff back in there as well. So great. Really appreciate it, Mike. Thanks so much. We may have a few more questions in the chat that we might want to get into as well after the show. But thanks again. Look forward to seeing you on the next one.
Pleasure.
Yeah.
Thank you.
Yeah. Thanks for joining us.
All righty.
Bye-bye.